All right, convert sorted array to binary search tree. Given an array where elements are sorted in ascending order, convert it to a height balanced binary search tree. For this problem, a height balanced binary search tree is defined as a binary search tree in which the depth of the two subtrees of every node never differ by more than one. So given the sorted array, we have -10, -3, 0, 5, and 9. One possible answer is 0, -3, 9, -10, 0, and 5, which represents the following height balanced tree. So this one's kind of confusing if you're unfamiliar with binary trees. A binary tree is basically where you have two nodes, or you have a node that has at most two children, a left and a right node. And so this is our sorted array. And what we want to do is a pre-order traversal. I mean, you can do other ones. I'm just doing the pre-order for now. It's most convenient, which we're targeting the root node, the left node, and then the right node. So the pre-order traversal looks like we hit 0, which is going to be our root, and then left, right, and then we've gone as far left as we possibly can. Then we would try to go to the right would be null, we'd go back up here, the right would be null, and then we'd go here, and then we would go to the right. From 9, we would, typically, if you're doing a pre-order, you print out the nodes. So we would print out 9, and then we would go left, and then it would hit null, but we would basically be done with the tree. So yeah, that's all fine and dandy if the tree is already built out, but we need to build out the tree given a sorted binary tree, or given a sorted array. So what we really need to do is isolate the middle node every single time we're traversing through the tree. So starting with the middle node, which would be 0 in this case, that would be our root. And then we need to isolate the left half of the tree and the left half of the array and the right half of the array. And by doing that every single time, we'll be able to recursively keep isolating our middle node and create a new tree node that we can add to the tree. So if we would start off going basis of our pre-order traversal, when we hit 0, our left, so just going off of this, going off of the sorted array, our left becomes -10, -3, and our right become 5 and 9. So now we could just repeat that process on each left and right. So when we hit the left, we'll know, hey, our left node's going to be, the only thing we can have left in the array is 10, so we know that'll be our left, and the right will be null. So whenever the array's length is 0, we know we need to return null, and that'll be our child node. And then 10, we have null. There is nothing in our left array, there's nothing on our right, so we can just return null. And then when we hit 9, we would only have a left of 5, and our right would be null, and then the same thing for 5. So our time complexity is going to be O of n, and our space should also be O of n, where we have n is the nodes in the finished tree. So traversing the tree and then creating the nodes, if that makes sense. I'm kind of getting to the code, and you probably need to see it for it to make more sense. But so we're checking if the length of our array is 0, then we're going to return null, because that means we're at the base of the tree. And then now we need to grab our mid element. We need to grab the middle element in the array. So we can just do math.floor nums.length divided by 2. And now we need to grab the left. So I'm just going to use nums.slice, which is 0, and mid. And this just creates a clone of our original array. And then we can grab our right, which would be nums.slice mid plus 1, and then the length of the array. So this will grab the left subarray and the right subarray. Well, that's fine and dandy, but what are we going to do with our nodes? We need to create a tree here, right? So we can create our root by doing a new tree node with our mid value, and then ultimately we will return our root. And now we can assign the left portion of our root node to a recursive call of our original function, which will just keep repeating this process until eventually we hit null, and then the recursion will collapse on itself. So we can do sorted array to BST, and then we would just call in left, which is going to be the left sub array that we had, and then as far as our right, we'll do the same thing, sorted array to BST right. And so this is it. Every single time we're building out our tree, we're building out the left nodes first by recursively calling the subarrays, which just goes through this process and keeps grabbing each mid until we can't. Ooh. And then, yeah, that's basically it. Cool. Like, comment, subscribe, and I'll see you in the next video.